Exploring the field of magnet. Materials that you need: plotting compass, bar magnet, U-shaped magnet, iron filling, ball pen, paper, and plastic plate. Task 1. Place a bar magnet on a sheet of paper. Draw the outline of the magnet. Place the plotting compass near the north pole of the magnet. Mark a dot on the paper in front of the compass needle. Move the compass in such a way that the tail of the needle is on the dot you mark. Mark the new position of the compass needle. Draw all the positions of the compass needle around the magnet. The orientation of the compass needle around the magnet shows how the field continues unbroken from one pole to the other. The lines of induction are not equally distributed within the magnetic field. As you can see in the captured magnetic field pattern, more lines of induction are found at the poles than at any point in the field. This shows that the field is strongest at the poles. Task 2. Place a bar magnet under a plastic plate. Sprinkle some iron fillings on the plastic plate. Tap the paper gently and watch the pattern of the magnetic field. You can see pattern of magnetic field lines by sprinkling iron filling near the magnet. The iron fillings arrange themselves in such a way as to show the magnetic field lines. Task 3. Place a horseshoe magnet on a sheet of paper. Draw the outline of the magnet. Place a compass needle near the north pole of the magnet and mark the positions of the pointer as in part 1. Draw lines to represent the path of the compass needle. Task 4. Place a horseshoe magnet under a plastic plate. Sprinkle some iron fillings on the plastic plate. Tap the glass gently and watch the pattern of the magnetic field. The magnetic field was made visible by sprinkling a layer of iron fillings on a plastic plate laid on top of the magnet. The fillings are shaped like tiny needles and orient themselves with their long axes parallel to the magnetic field at each point. The field pattern is slightly unsymmetrical, showing the magnet's right hand pole is slightly stronger than its left. Task 5. Arrange two bar magnets so that their opposite poles face each other. Place the magnets under a plastic plate. Sprinkle some iron filling on the plastic plate. As you can see, it's being pulled together as the two magnets attract each other, so that a good representation using iron fillings, we can actually see the shape, direction, and the interaction between these two magnets with their magnetic field. Task 6. Arrange two bar magnets using like poles of a bar magnet facing each other. Place the magnets under a plastic plate. Sprinkle some iron fillings on the plastic plate. As we sprinkle the iron filling, it shows that when two like poles, two bar magnets are placed here, each other, the magnetic field lines also repel us, move away from each other. Magnet can magnetize or attract other magnets and magnetic materials. A bar magnet has two poles, a north pole and a south pole. Magnets create magnetic field around them. It is the space around the magnet where the magnetic force is felt by another magnetic material. This field causes the attractive or repulsive property in magnet. Like poles of magnet repel and unlike poles in bar magnet attract each other. The magnetic field of a bar magnet is represented as closed line between the poles of the magnet. The direction of magnetic field is conventionally taken from the north pole to the south pole of the magnet. The magnetic field of a bar magnet cannot be seen. Its presence can be felt using iron filings. The tiny pieces of iron filings gets lined up in the direction of magnetic line force.